Welcome to the Trellix Spotlight Series. My name is Nick, and I will be your host. Today's session will focus on endpoint security, adaptive threat protection best practices. This webinar will be recorded. If you prefer not to participate in the recorded session, please feel free to disconnect at this time. A link to today's recorded presentation will be emailed to all registered attendees. This webinar is a brief overview covering common use cases and scenarios regarding this topic. It is not intended to be all-encompassing. If assistance is needed, please contact Trellix Technical Support. If you have questions during the webinar, please type them in the Q&A window. This webinar may run longer or shorter based on your participation, and we recommend asking as many questions as you can to make the most of this series. If the Q&A window is not displayed, click the tab at the bottom of your session window and click on the Q&A icon. We will answer the questions during the final section of this webinar. If you experience any audio issues during the webcast, please drop and attempt to reconnect. Our presenter today is Aaron Katawar. Aaron joined Trellix in June of 2010. In his role at Trellix, he provides support for all Windows-based endpoint security products. Ladies and gentlemen, Aaron.
All right, thank you, Nick. So welcome, everyone. We're going to go through the agenda real quick. We're calling this ATP Best Practices. There is some more information outside of best practices. We're gonna go through an overview, look at some configuration pieces, and then talk about some best practices. We're, as much as possible, I do want to get within EPO, view the policies. We should actually have a chance to play around with some unknown files too, so we can see how they behave and put that to practice. But we do have some slides to go through. I want to start with this overview. If there's some misconceptions or some or if it's not clear really what this product does, what it's intended for, how it behaves, then the best practices don't really mean much to anybody. So with that being said, we'll go through each section, and then after each section we'll put some of that to practice. All right, moving right along. Let's go through the overview. I need to make sure everybody understands what this product is, what it does, what it's intended for, right? Now, keep in mind with ENS threat prevention, you already have a file level scanner, right? That looks for malicious content based on what's in the AM core DATs. So adaptive threat protection is a little different, right? It scans processes on execution, and that's all it's intended to do. So it doesn't directly scan files on disk. You've already got a scanner for that, right? You've already got threat prevention's on access scanner for that, or the on-demand scanner. So if you take the example of like an ICAR text file, you can't expect ATP to give you detection on something like an ICAR test file copied to disk, right? That would be your on-access scanner. It will, however, monitor what Notepad is doing, right? The process that actually opened that text file. And if something malicious is found with the process, then we expect an action to occur based on whatever reputation is assigned to that process. And when you start talking about the actions that ATP can do, you're essentially looking at a block or a clean action, and then you have DAC, which can do a contain, right? So if this process that accessed a malicious file has malicious behavior, and it reaches the reputation for a clean action to occur, then of course we expect ATP to clean or remove or revert back anything that this process performed. So it does have cleaning operations, right? But it's not going to. You can't expect ATP to just action a file on disk, right? At this point, the product consists of what I would consider 8 major components, and it's a lot. The product itself essentially installs a single service, and then there's also Rule Protect. Part of ATP is what we refer to as Rule Protect. There's some Rule Protect content that needs to be installed with it. But this thing's got pretty much what I would consider 8 major components. So we'll go through those real quick. There's JCM. This is just think of it as a reputation store, right? There's many different sources for reputation. When those come down to the endpoint, we expect all of those reputation sources to provide input to the JCM cache, so that when a process is executed, first step, check the JCM cache. What do we already know about this, right? And then you move on to, so that could be considered kind of the front or the first level scanning, if you will. At that point, it goes into JTI. We commonly refer to those as TIE or ATP rules. JTI just stands for Joint Threat Intelligence. And I'll when we go into EPO, I'll show you a representation of that JTI rule stack. It's actually in EPO in the server settings. Then we come into Rule Protect Static. This is there's the Rule Protect piece of ATP. I think earlier on when this product was released, there was some confusion on calling it ATP versus Rule Protect. Rule Protect is a piece of ATP, right? There's the Rule Protect Static and the Rule Protect Dynamic scanners. The dynamic scanner is the cloud-based scanner. So we'll, in working with support or speaking with people about this product, you might hear Rule Protect Static, also referred to as Rule Protect Client. That's fine. Two names for the same engine and content. And then Rule Protect Dynamic, you could also hear it be referred to as Rule Protect Behavioral or Rule Protect Cloud. Three names for the same component. And then we have a DAC piece, that's dynamic application containment. That's your containing piece, depending on the reputation of the process and what the configuration of the product is set to, will allow the process to run in a container to further evaluate the behavior of the process. I will say that ATP is not solely meant to be a DAC container, right? It's the idea behind the product isn't simply to set DAC to contain all unknown software in the environment, right? You will run into legitimate business applications being contained, but we should talk a little bit more about that a little bit later in the presentation. Then you have your AMSI piece. That's Microsoft's anti-malware scanning interface. We refer to it in the policies as enhanced script scanning. That came about with the 10.6 release. Not a lot of configuration to that, right? So if AMSI is involved in some type of detection, you're essentially looking at an exclusion, right? If it's something you trust, if it's a legitimate business application, or you're looking at perhaps disabling AMSI scanning where you need to. Then there's credential theft protection. This is really a good comparison would be like the access protection feature for threat prevention. Essentially, if you can think of this as like an access protection rule that's just monitoring reads against the LSAS process. And there is a high level, there's a list of processes that are allowed to access LSAS based on the content. If that process is not on the list, block it and throw your CTP block event. There's really nothing too magical about that piece. It's just preventing reads to the LSAS process. And then the last piece would be what we call the enhanced remediation engine. We also refer to it as the deep remediation engine. And this is essentially your cleaning piece. This is the piece that tracks file changes, right? Changes on the system, so that if a known, well, at least with default configuration, if a known malicious reputation occurs for a process, and provided somebody hasn't disabled enhanced remediation, this is where your cleaning comes into play. And the enhanced remediation engine will restore the system to its prior state. So all of these are important pieces to the product. They are designed obviously to work together, except for really the AMSI piece. AMSI is kind of while it is built into ATP, and there's also an AMSI scanner in threat prevention, right? But this AMSI piece is kind of a separate piece. Pretty much everything else works in conjunction, intended to work together to establish an overall reputation. I would probably include CTP in that too. AMSI and credential theft protection are kind of, while they're built into the product, they're kind of operating separately, right? Whereas JCM, JTI, the RealProtect scanners, credential theft protection, and enhanced remediation engine, these are all working together to get you an established reputation. Nothing too crazy here. This is essentially just showing kind of the flow of checks that the scanning goes through. We're obviously checking from a whitelisting perspective, we're checking certs and hashes, right? Do we already know what this is? Is it known clean? Do we even need to check it? Things of that nature. A lot of that is done through the content, through the AM core content. GTI reputation, of course, if you have a TIE server, that does definitely add some functionality to the product, then TIE is considered, and that would be part of the JTI scanning. And I'll again, I'll show you the rules a little later on for the JTI rules. Then your RealProtect static code review, right? Basically, fancy way of saying RealProtect static is scanning that process behavior. Probably the important thing to note here, you'll notice how there's this post-execution for these asterisks here, right? All of this prior to DAC is considered pre-execution phase, right? So JCM, JTI, RealProtect static, that's all pre-execution. Once it gets past the RealProtect static phase, now we're at a post-execution, right? We're at post-execution phase, and that's where your DAC and the RealProtect behavioral, RealProtect Cloud, RealProtect Dynamic, that's where those come into play. We'll essentially, depending on the reputation, of course, we'll essentially contain it with DAC, right? Allow it to run in that container. And while it's evaluated against DAC rules, it's also being evaluated against the RealProtect Cloud engine and content. There are definitely some requirements and limitations to this product. I've got noted here at KB that we'll talk about some operating systems that it's not supported on. Welcome to go check that. They're not widely used OSs, right? So it's pretty much compatible with any latest and greatest OS that's out there. Internet connectivity to the Trellix GTI cloud is very important. There's a false positive mitigation feature that's built in the product. You really can't see it, really can't do anything with it. It's just there running in the background. And that GTI cloud connectivity is required for that to function. RealProtect client also makes use of the GTI cloud. So, I think one of the common things that we'll get questions on, or we'll get service requests open for, is failing RealProtect test file detection, right? So we have a KB with test files. How do I make sure ATP is working as it should? Kind of like the ICAR test file for threat prevention, right? For the on-access scanner for threat prevention. And 9 times out of 10, whenever we get reported failing test file detection, it's because those systems cannot reach the GTI cloud. Right, so that's a pretty important piece. There is an offline scanning mode for RealProtect. We'll look at that a little bit later, but essentially that forces the product to not make use of the cloud, right? And we'll talk a little bit more about that in the best practices section. Definitely requires installation of threat prevention. This kind of sits on top of threat prevention as a complementary scanner, right? Like I was saying earlier, you've already got threat prevention for disk activity, file activity on disk. This requires threat prevention to make use of certain pieces and to know when it's supposed to scan these processes on execute. Right? It cannot. I want to state this. This is something that we should have another piece on this in the best practices, but it's worth mentioning here. You can't configure ATP to delete, or take an action against any process you want, right? There are certain processes that have a trusted by Trellix, we'll say, right? A known trusted to us certificate. And as part of the trust built into the AM core content, those files cannot have a reputation overridden, right? So even if you have tie connectivity and you have the metadata for that file in tie, you can't go in and simply set it to no malicious and expect ATP to nuke it off of the machines, right? There's not a defined list for those. We don't share that for obvious reasons, right? But I will take y'all through a little bit later on in the presentation. I'm going to show y'all a very easy way to run an unknown application, something that's completely unique. And if you have tie connectivity, it's very easy to run that and see it get submitted to the tie reputations page and then change reputation for it within tie. It can't, the next statement here, the ATP cannot block or clean any file added to the tie reputations page kind of goes along with that. What I'm really referring to there is that there's been a lot of scenarios where service requests are open, and and the problem statement is usually something like, I'm trying to set this reputation in tie and it's not being honored by the endpoint, right? It's not being honored by the product on the endpoint. I'm not getting detection on it. It's broken. It's not working, right? And we start digging into it, and what we find is that the files that were added to the tie reputations page, they're not PE files. They're not portable executables. So you can't take something like a batch file, right, or a PDF, right, or a text file, add it to the tie reputations page, change reputation on it, and then expect ATP on the endpoint to start nuking those off of all the machines in the environment. Doesn't work that way, right? And I think that's the piece that we've got to make sure that we're clear on. ATP, you can, for tie reputations, and this is separate from ATP functionality, you can import whatever list of files and metadata for those files that you want into the tie reputations page, right? It could be text files, PDFs, batch file, whatever you want, right? The product, though, ATP is a product. It only scans portable executables, right? So, of course, most common EXEs, DLLs, right? Scans processes on execution. I think screensaver files are PE files too. I'd have to check .scr files. So I commonly, well, I wouldn't say commonly. Every now and then I do see a question of or a service request come in, and the problem statement is, hey, I'm adding these files to tie. I was told I could add these files to tie, and then I could set them to a no malicious reputation. And now my expectation is that ATP goes and nukes them off all of the machines. And that's true if they're PE files, right? But you can't take something like a PDF file, throw it into tie reputations, set it to no malicious, and then expect ATP to start blocking it or cleaning it off all the machines. Doesn't work that way. And that might be that might be how we've presented the functionality of the product in the past. It's a possibility. So I definitely want to call that out and just make sure we're clear that ATP is only going to scan processes on execution, right? The other, I have this in the requirements and limitations section because it's important to call out. The ability to exclude something from ATP actually comes from us editing the threat prevention on access scan policy. And I will show everybody that within EPO. I get it. It sounds weird. Why are we modifying threat prevention's OAS policy? Thought that had nothing to do with ATP. That's true. But ATP is designed to pull exclusions that are added into the on-access scan policy, specifically the standard tab. And I will show everybody that within EPO when we get into EPO. All right, this next piece is essentially going to walk us through using the observe mode feature of the product. Highly recommend using this. ATP isn't one of those things that you just blast out to the entire environment, right? It's not as simple as something like the Trellix agent. Anybody that might be familiar with ENS Firewall's adaptive mode, pretty much same thing, right? It gives you the ability to determine how is this product going to behave in my environment, allow me to change configuration to meet my requirements before I actually go back and allow the product to start blocking, cleaning, containing, right? Allow it to actually take those actions. So we're going to go through some of the finer points of using the observe mode, and then we'll get into EPO and we'll walk through those steps. All right, so first and foremost, all this is really saying is in the ATP options policy, you've got to enable observe mode. It's not enabled by default, right? So pretty much step one, make sure in your policy you've got observe mode set. The other recommendation I have here is that for this pilot phase, right, for this using this observe mode, use the default DAC policy. And the reason I say that is because it has all of the DAC containment rules set to report only, not block, right? The other thing to be aware of here, in order to receive the observe mode events in EPO, you have to modify the common options policy, and specifically you want to pull in the ability to log events of warning. The default's critical and alert, so we've got to change this at least to warning, critical, and alert. You could go with all or all except informational. There's really no need to for observe mode. You just need to make sure you're allowing these warning events to be logged. And again, I will show that to everybody. The other thing to keep in mind, and this is just my own personal recommendation, right? I like to get my system set up with common platform and threat prevention, make sure they have content, right? And make sure that piece is fully functional, the system's reporting back to EPO, and we're good to go there before I deploy ATP. The reason for that is that 99% of the time, any type of installation failure, it's going to be due to the common platform or threat prevention, not ATP. ATP is actually very simple from a software deployment perspective. It's just a service, and then once ATP is installed, it needs content, right? So it's actually really simple. All of the other pieces that are needed for this to function, well, they come with common platform and threat prevention. So if you're going to have an install failure, most likely it's going to be that piece. Now, you don't have to do that. You can actually send down a product deployment task for just adaptive threat protection, and the installer has the logic to know that it also needs common platform and threat prevention, right? So you don't have to do it this way. It's just something I like to point out. I personally like to make sure those pieces are good to go and I have no issues there, and then I go back and get ATP deployed to the systems. And this is just saying the same thing that I just it's just pointing out the same thing I just said. Get the required products installed, get all that ready to go, and then do your ATP deployment task. In terms of the events, you can, under the reporting, there's a specific section for the adaptive threat protection events, and it just essentially just filters out any other product events, right? Don't have to go there. You can go to the threat event log if you'd like, but there is a specific section for that in EPO. The idea behind this observe mode is really to alert the administrator as to how the product's going to behave, right? Because you have to keep in mind this is all behavioral based scanning, right? So when we get into talking about ATP taking an action on a legitimate application, something that's trusted by the environment, they know what the application is. They know it's not malicious. Maybe it's something that does PowerShell execution, right? The the topic of false detection is, I think a lot of times we incorrectly apply that logic to something like a DAT false, right? A DAT false involving threat prevention's on access scanner or on demand scanner, right? In that context with threat prevention, with ENS threat prevention, it's the content needs to be changed, right? It's falsely detecting this legitimate file on disk. We get our samples, we go to labs, they're going to give us new content, right? Stop that false detection. When ATP detects something that we trust, we refer to it as a false, but if you think about it, it's just a behavior, right? So a common malware behavior could be for PowerShell to run encoded commands, right? Something that's simple, right? So if you have an application that is legitimate, that has a need to execute PowerShell, that uses encoded commands, expect ATP to quote unquote false on that application. Doesn't mean ATP is doing anything wrong. It's supposed to be monitoring that behavior, right? So the idea behind this observe mode is start giving me events that I can look at and see which ones of my applications are legitimate that it could be falsing on, right? And I'm going to go ahead and make my configuration changes so that we can avoid that whenever we take the product out of observe mode, right? And then you have to keep in mind when it is in this observe mode, it's not protecting the systems, right? It's just monitoring, it's just reporting behaviors that would occur, would contain, would block, would clean, right? Now we go make our modifications, and then when we're satisfied, when we're ready, we go take it out of observe mode. Now the product can actually take action. So observe mode isn't something you want to set across your entire environment if you've already got the product deployed out to the entire environment, right? All right. So now that we've been through that section, what I would like to do is go ahead and hop into EPO, and we'll go through how to set up this observe mode. Okay, here's my lovely EPO server, which we're actually going to use the EPO server for this demonstration too. I'm going to use this system here. But first things first, policy catalog. I've created these policies based on the defaults for this purpose. And you'll see here, I've got ATP in observe mode. The other thing I'm going to do, and yes, I understand earlier that I mentioned that setting DAC to contain an unknown is not a best practice, and it's not, right? It can interrupt legitimate applications frequently. That being said, I understand why it's a more stringent security posture. So if that's the desire, then just know that as part of this pilot phase, you're likely to get a fair amount of containment events or would contain events. I'm going to set mine to unknown to save some time, just to make it, just to make sure that we're actually taking an action against this unknown application that we're going to use to test this. So I'm going to set mine to unknown here. The other thing, like I was saying earlier, make sure you're going into the common options policy. And in this common options policy, you'll have to show advanced. Mine's already showing. Come down to your ATP events to log and change it to warning, critical, and alert. Again, that's the default, so we're just switching it to warning, critical, and alert. You can do all except informational or all if you want. There's really no need to for observe mode though. We just need to make sure we've got the warning in there. All right, so to save some time as well, I've already deployed the product. It's good to go. I know it's got good communication to EPO. It's enforcing policy changes. So I've already set all that up. Just to be safe, I'm gonna go ahead and just check new policies. Just make sure. I do see, I think most of us are in a habit of doing collect and send events, check, enforce, which is fine, not going to hurt anything, but it should just be enough to do check new policies. All right, so to test this out, what I like to do, there's many different methods to do this, but what I want to do is create a completely unique application that's unknown to GTI, right? And so if you have 7-zip on the machine, you can create what's called a SFX archive. Pretty easy to do. Get you a new text document created. We'll just name this ATP webinar. Make sure you put some content in the file, right? You don't want it to be a 0 KB file. And then go to your 7-zip options, add to archive, and you're just going to select this create SFX archive. That will create you a completely unique application to test through the scanners, right? And it should just be a matter of running this. You don't have to extract it. All right, so the fact that I've already ran this, it should have already given me, as soon as I send events, it should give me a would contain event for DAC, right? Again, because I set DAC to contain it unknown. So let's just make sure, we shouldn't have to wait long for those events, but let's just make sure they're coming up. Got some events that were sent there. And then I'm going to go into the threat event log. And here is my would contain. All right, so with DAC containment events, generally my advice is just stick to the event. I wouldn't worry about the log. The event actually gives you more information than the DAC activity log. I'm not typically going into the debug log either. Just use the event. It gives you everything you need to know. All right, all the system information, the process, right, the target file, which is the same here for this example. But what you'll notice here is ATP would contain. All right, and that lets you know anytime you see would contain or would block or would clean, you should immediately be thinking, oh, that system, ATP on that system is in observe mode. That's the only way that you're going to get an event that said would in front of the action, right? So it's here, gives me all the information I need to know about this application. If I trust this application, right, then what I would want to do is exclude this from DAC containment before I take ATP out of observe mode. How do I do that? Pretty easy to do. And this is actually separate from an ATP exclusion, which I promised to show everybody. I'm about to. But for a DAC exclusion, you're going to come into the ATP policies under DAC. The one I have assigned to the system is this ATP webinar policy. Show advanced, add your exclusion. Give it whatever name you want. Exclude ATP webinar. This is just the name of the exclusion, right? And then it's enough if you just put the file name. You can do that. You're welcome to path out to it as well if you really want to, right? You can put the full path. And then you have these other options here, MD5 hash signer. The more you add, the more parameters have to match exactly to honor the exclusion, right? But it's actually really easy. You just add, at its basic form, you just add the application name here, and you're done, right? And now for this system, right, when this process is executed, if the reputation is unknown, DAC will not contain this application, right? Now, if you have TIE, feel free to go into TIE and change the reputation. To show y'all what that looks like, I do have TIE set up. I will come into my TIE reputations, if I can find it here, right here. And one of these is my ATP webinar EXE. I was playing around with it. So The latest one here, let's just look at the time. Let's see, 2:42 on that one. 2:34, that's the old one. So here's the latest one that that we just tested with. And you'll notice that the latest local reputation is unknown. That the latest local reputation comes from the product on the endpoint. That is ATP telling TIE, I believe this process to be unknown. Right? So this is just a reputation input into TIE. Now, what can I do to override that? Pretty easy. Come in here, set whatever reputation you want. Right? Now, if you don't have TIE, you're really kind of limited because you're going to be doing an exclusion. You're going to be doing a DAC exclusion, right? Or you can do an exclusion through all of ATP, but keep in mind that excludes it from all ATP components, not just DAC containment. So when we talk about exclusions for the product, you've got DAC exclusions if you want something to be excluded from being contained from DAC. But then you have ATP exclusions. And if you exclude from ATP, you're excluding it from all of ATP, not just DAC, right? Now, what does that exclusion look like? Told y'all I would show you. So in the policy catalog, under threat prevention, on access scan, it's just like adding a file exclusion. You can do a folder exclusion too, to threat prevention's on access scanner, specifically under the standard tab. Doesn't matter if you're using the high risk and low risk, none of that applies. ATP only looks for file and folder exclusions added to this policy under this tab. So you're going to add it here. And again, you can do a simple file exclusion ATP webinar. If I can type today. Right. If you wanted to do the path, feel free to do the path, C : whatever path, right? Doesn't matter. You can do the path to the process, a little bit more secure in the exclusion. You can also do folder exclusions if you want, right? If you were to do something like, well, we know this is on the desktop. So if I did something like that desktop / to denote a folder exclusion, then any PE files executed from that directory will be excluded from ATP scanning. So be careful with that, right? Be careful with your folder exclusions. I would say for the most part, most folks are probably going to want to put the path to the actual process they want to exclude. And again, I can't say this enough. Make sure you understand that this is going to exclude it from all of ATP scanning, not just DAC containment. But it will also exclude it from DAC containment, right? Let's see. The other thing that I mentioned I would show everybody before I forget is let's go look at the server settings and the adaptive threat protection category. These are all the TIE rules or JTI rules or TIE/ATP rules. We call them 3 names for the same thing. So you're welcome to go through this. We're not going to go through all these rules here. Obviously, don't have the time for that. But these groups refer to your rule assignment in the ATP options policy. You're welcome to go through these and see exactly what they say. But this is just part of the scanner, right? This is just the JTI scanning rules. One of these rules, I'll show it to you here. I believe it's 93 or so. Yeah. Certificate reputation, enterprise file reputation. When we talk about enterprise file reputation, we're talking about reputation that was manually added to that process in TIE, right? I went into TIE and I set an enterprise override and changed the reputation. So this is where you get your TIE lookup as it passes through JTI scanning. You get your TIE lookup, the product will submit metadata, submit the file to TIE, right? And then that's where you get in your TIE reputations page That's where you get to come in here and do whatever you want to do with the file, right? Set some type of override. I think this is probably the problem statement of I changed something, I changed reputation and tie for this application. It's not being honored by the product on the endpoint. Please help, something's broken. It's a very common problem statement. And they can be easy to diagnose. They can be very difficult to diagnose. One of the little pieces of information I'll give everybody from a log perspective, when you come in here and change this reputation, I'm just going to put it to fine. We'll put it to known trusted. In fact, I tell you what, let's set it to malicious. Let's set it to malicious and we'll generate another event. No malicious. All right. Now, if that application is still running on the machine, you should see within a couple seconds, you should see a detection occur, an ATP detection occur. Right. If it's not still running, you'd have to launch it again. So I'll launch it here in a second. But what I would like to show to everybody the ATP activity log is very useful. You can get a lot of information from this, even without debug logging enabled. If you want to actually see the actual reputation exchanges, you have to use debug logging. But you normally in that scenario, you're already working with support and we'll help you with it. But what you should notice here is, if I can find it, here we go. That might be kind of hard to see, but here's the reputation change, rep change listener. This is when I changed it to no malicious. So enterprise reputation of file, C user administrator desktop ATP webinar changed to 1. 1 is malicious, no malicious, right? 99 is trusted, 1 is malicious, 50 is unknown. So you should not have to go into this full debug mode with AMTrace and proc1 and all this stuff just to determine whether or not your reputation change made it down to that system, right? It's right here in the activity log. So now my expectation is that if I run this again, right, it was already closed out in the background. Now I'm still in observe mode, right? Remember, so there's not going to be any pop-up or action that you see, right? But I should have a new threat event. Right? I should have a would clean because it's no malicious, and by default, product is set to clean at no malicious. So let's send events. Looks like some events came up. Threat event log. And here's my would clean right here. All right, tells me the source process name that executed it, the target. Would clean. So just from seeing this, I know this system, ATP on the system is in observe mode, right? And now I have some decisions to make. What do I want to exclude this? Right? Or do I want to go into tie if I have tie connectivity and change the reputation, do some type of enterprise override? Like I was saying earlier, again, if you would like to engage us for a potential false positive escalation, we have that ability. We'll be more than happy to send it to the content team. Just know that it's not often that they actually make a change to the content, right? Because again, this is all behavior based, right? If my behavior is never to answer my door, it doesn't matter if I trust the person knocking at my door, I'm not going to answer the door. I have to make an exception to change my behavior, right? Okay. Let's go back to our presentation. We've just got kind of a list of some best practice stuff. All right, for this section, it's essentially a list of some of these best practices. A lot of this we've already talked about, but we'll go through them real quick. We haven't talked about this yet. Make sure these modules are from the same release, right? So Common Platform, Threat Prevention, ATP, they all work together. Don't run Common Platform from September 2021 with ATP from June 2022 is all this says, right? We QA against that release. We don't QA against mixed releases of these blades, if you will, the Common Platform. Don't set DAC to contain an unknown. Oops, sorry, let me go back. Yes, I know I did it in our test. That was just for me to easily fire off an event. Again, it's your environment. If you want the more stringent security policy, I get it, I understand. Just know that you will have to do custom configuration, whether that's a DAC exclusion, if you have ties, setting the tie reputation, setting an enterprise override, or excluding through ACP. Yes, you are welcome to engage us, open a service request for a quote unquote false detection. We'll send it to the content team. Just know that there's no guarantees that they're going to change the content because that impacts everybody using the product. All right, I have seen them change content on occasion. It's just not that often, right? Usually they'll come back and say, sorry, we can't do that, do an exclusion. And then there's a KB for best practices for DAC containment, this 87843. Don't leave debug logging on. We stress this with the TSEs. When they're using debug logging, make sure they're going back and turning it off. We're human, we forget. So as a customer, if you're working with support or if you enable debug logging, make sure to go back and turn it off. It can lead to high CPU of the MFE ATP process. We're meant to use both scanners with this product, right? That both rule protect scanners. We want to use them in conjunction with each other to get the best overall assigned reputation. So it's really its full power comes from utilizing both of those scanners. Both of those scanners need to make use of GTI reputation, right? Now on systems without internet connectivity, really kind of defeats some real protect features. Number one, your cloud scanner isn't going to function. So you might as well go into the policy and turn it off. Real Protect Client, there's an offline scanning mode. So if you have systems running ATP that you know will never have connectivity to the GTI cloud, go ahead and disable the Real Protect Cloud scanner and then set the Real Protect Client scanner to its offline mode, and that'll prevent the lookups from occurring. Don't allow any inspection into those lookups. That can cause them to fail, cause those lookups to time out. That can sometimes lead to a performance issue. The sensitivity level default is medium. This is not GTI sensitivity. If you're familiar with what we call it Artemis 2, Artemis sensitivity levels for like the on-access scanner for threat prevention, not the same thing. This is actual Real Protect sensitivity. Leave it at medium, right? If you raise it, chance of increase in false detections, false positives, right? Lowering it can reduce its efficacy. So the scan process is started from network drives. I would test it out. We don't recommend turning it on. It's a better idea to just protect the system where the process is running from, right? Because it can incur a performance hit. So if you think you want to use this, test it out first, right? See how it behaves in your environment. The three rule groups, we looked at them earlier in the JTI rule stack. There's the balance, security, and productivity. Best practice, just use the balance. The difference between those is that if you compare like balance to security, the security rule group has more rules set to enabled. It looks for more behaviors, right? Observe mode, I'm pretty sure we beat that topic to death. This is just saying, hey, before you blast it out to the environment, use observe mode and configure it to meet your needs. And then these are just some use cases. Like if you have developer systems where they're constantly changing application binaries, those are going to be unknown to GTI, unknown to Trellix. So kind of goes back to containing unknown, right? Expect that stuff to get contained, have to do some policy configurations. So observe mode can just help you get the good policy set for different systems in the environment. The activity log, we briefly looked at that earlier, showed you the reputation change from Ty. I spend most of my time here, honestly. I think we did a pretty good job about logging what is happening in this activity log. There's only a handful of scenarios where I might request debug logging, but for the most part, use this activity log. It's got a lot of good information in there. Even exclusions, right? If the product is properly honoring an exclusion, it'll be listed in the activity log. And then just stay up to date. I get it. I know every support TSE you talk to says update the product, update the product. Hey, you're a patch behind, update. There's lots of reasons for that. We don't necessarily always voice those clearly, but it's just to avoid issues we've already fixed in the past, right? That kind of goes along with these additional resources. These are just product guide, install guide, some references to this documentation. One of the things I wanted to point out, this known issues article, there's a human factor here. Somebody has to go update this article, right? What I usually recommend, I like the release notes, right? So if I'm, say, 2 versions behind and I have an issue I think is related to the product, I like to go see what we fixed in those next 2 versions. Those will be in the release notes, but keep in mind, those are tied to customer bugs, right? Anything we find internally, we do not put in the release notes. So that's one of the reasons why a support TSE might say, hey, I see you're behind. Can you try, as a test, can you update the product to see if the issue continues? Because we'd like to troubleshoot the last version, right? And there are things we fix that are not documented in those release notes. So just keep that in mind. This is just a KB about the SSL inspection. This is one on resetting the JCM cache. Really, and I've worked some issues related to this. If you're in a scenario where you're finding that in order to solve something or enforce a reputation change of that nature, and you're constantly having to reset the JCM cache, open a case with us. That's not there. There is a time to live for the cache, right? But you shouldn't have to constantly go in and reset the JCM cache. There are some scenarios where you have to do that, but it shouldn't be a constant thing, and it shouldn't be considered a fix in any way, right? And that's all I have today, folks. Really appreciate everybody joining, and I will go ahead and hand it over to Nick because I believe we have a QA session.
Thanks, Aaron. As a reminder for everyone, Trellix Education Services offers exceptional training to go along with our award-winning products. If you would like to learn more, please visit the website listed on the screen to see all of our offerings. Are you wanting to learn more about upcoming Trellix product features and innovations? Join Trellix technical experts in a weekly 30-minute Tech Talk webinar series. Every week, you'll get a peek under the hood at Trellix technology and see a short demo spotlighting key capabilities from across the industry's most comprehensive portfolio of cybersecurity solutions. Now let's get our Q&A session started. I see we have several questions, but it's not too late to add your question. Please type it in the Q&A window to submit. Additionally, take a moment to fill out the survey. Your feedback and suggestions are always appreciated. Does adding a process to the ENS threat prevention low risk profile while also disabling scan on read and write exclude that process from ATP scanning?
No. So as we presented in the presentation, the exclusions for ATP, it's only looking at the standard profile, if you will, or standard tab in the on-access scan policy for threat prevention. So I think there is a misconception that if somebody's using the standard high and low risk profiles for on-access scanning, and in low risk, if they add a process and then turn on the option to disable scan on read and write, that will also prevent ATP from scanning that process when executed, but that's not true. So ATP will only honor the file and folder exclusions that are in that standard tab, regardless of whether or not the on-access scan policy is configured to use the 3 profiles, the standard, low, and high risk.
Got it. Okay, perfect. Thank you for that one. How does the AMZ scanning within ENS ATP differ from AMZ scanning within ENS threat prevention?
Good question. So it is a little confusing because if you have both products, you will notice that there is an AMZ scan component for ENS threat prevention. And then there's also within the on-access scan policy, there's an option for it. And then in the ATP options policy, there's also an AMSI scan component, what we call enhanced script scanning. The difference there is that the AMSI scan component for threat prevention will run those scripts and execute it in memory against the v3 DAT content that comes with the AM core content package. And then for ATP, it's going to run those scripts against the ML protect, what we used to call real protect. It'll run it against the ML protect content. So the scanning interface is essentially the same, right? AMSI is that anti-malware scan interface that Microsoft developed. And so ATP and threat prevention just plug into that, right? To give us the ability to run those scripts against our content, right? So if it's the threat prevention AMSI scanner, run it against the v3 DAT content. If it's the AMSI scanner and ATP, run it against the ML protect content.
Got it. Okay, perfect. Thank you for that one as well. How do JTI rules set to observe mode in the adaptive threat protection EPO server settings impact ATP scanning?
Good question. So in the presentation, we were talking about the importance of using that observe mode for like staging the environment for the deployment. And as part of that, we were talking about how if you get an event where the action says would clean or would block or would contain, then you can immediately kind of tell yourself, okay, I have ATP in observe mode. And that's true, but there is kind of a caveat to that. When looking at the EPO server settings and the adaptive threat protection piece, where you have your 3 rule assignments, you have your balanced productivity and security rule assignments, you'll notice in the JTI rule set that there are rules that are set by default to observe, right? And so what will happen there is that in the event that one of those rules is involved in identifying behaviors of this process that was executed, if that JTI rule would have blocked or would have clean, based on that reputation, that event will give you the same would block or would clean event, right? So there's actually two scenarios, and I'm glad this was asked so we can clarify it. There's actually 2 scenarios where the event would have that would clean or would contain. One is going to be that all of ATP is set in observe mode, right? The other one will be that a JTI rule, even when ATP is not set in observe mode, a JTI rule that is configured to be in observe mode will produce that event. And in that event, there will be a rule ID which will tell you which JTI rule was involved in that that would block or would contain event. Good question.
Got it. Okay, perfect. Thank you for that one. When setting an enterprise override within the TIE reputations page for a file, is that override automatically updated on all endpoints connected to that TIE server?
No. It's really more TIE functionality. I mean, it's we can't really avoid talking about TIE when it comes to ATP because they obviously integrate with each other. You don't have to use TIE, right? But there is that added functionality. But no, what that's basically referring to is that when you dig into the details of a file on the TIE reputations page, you'll notice that there's a field that says enterprise count. And let's say the enterprise count says, let's just say 10, right? That it'll just have a number. What that's referring to is that there are 10 systems in the environment that have requested reputation from TIE for that file, right? And the way that the TIE server stores that is it stores it by agent GUID. And so if you go into that file and you set an enterprise override, which is just, I think we discussed in the presentation, but anytime we talk about an enterprise reputation, we're just talking about somebody, the admin changed the reputation, right? They set an override. So if you go into that file and you change the reputation, you set an enterprise override, TIE will broadcast that reputation change to the 10 systems that previously requested that reputation. And you'll be able to see that within the adaptive threat protection activity log on those endpoints, right? There's an entry in the activity log. It's the key term to search for is rep change listener. It's all together, no spaces, REP change listener. And you can see where the enterprise reputation of that file was changed. And it'll tell you if it was changed to 1 or changed to 50 or 99, whatever it was set to, right? So TIE will only broadcast that change to those 10 systems, right? I think there's probably a misconception that when you change that reputation in TIE, that somehow TIE broadcasts this change to every endpoint running adaptive threat protection that's connected to that same TIE server through the DXL fabric, and that's not the case. It's going to send that reputation change to those 10 systems in this example, those 10 systems that previously requested that reputation, because TIE has their agent GUID stored, right? It knows that those systems ran that application previously, so it knows to update those systems. For all the other systems, it's okay though, because if that application is executed on those machines, and provided they have TIE connectivity, right, they will request the reputation from TIE, and TIE will give them the updated reputation.
Got it. Okay, perfect. Thank you for that one as well. When ATP cleans a file, it actually deletes it. It doesn't cut out the bad parts. Can you shed some light around the differences between a clean action and a delete action on a file?
Yeah, it depends upon, a lot of it has to do with the reputation, right? If you look at the ATP options policy, there's a setting for clean win, and then you have a reputation threshold. And by default, that should be set to no malicious. So that works kind of in conjunction, or it does work in conjunction with what we call the enhanced remediation engine. That was one of those eight, what I consider major components, one of those 8 components of adaptive threat protection. And so it depends upon the stage at which the detection has occurred, right? The cleaning will actually come into play whenever something makes it through the pre-execution scanning phase. So checking the JCM cache, checking the JTI rules, running it through ML Protect static, right? That's all your pre-execution. And then post-execution is DAC and Rule Protect behavioral, ML Protect behavioral, ML Protect cloud, ML Protect Dynamic, three names for the same thing, just because we like to confuse, right? But the post execution pieces, DAC and Rule Protect Cloud, is also where you get the enhanced remediation monitoring, right? And so if something is found in the pre-execution phase, just a delete, because there haven't been any changes to the system, right? But if it's post execution, whether it was contained or not, if there were changes made to the system, the expectation is that a clean occurs. And since the enhanced remediation engine is monitoring, unless somebody has disabled it for some reason in the policy, it's on by default. The changes tracked by the enhanced remediation engine is expected to go back through and revert those changes. Now, by default, the enhanced remediation engine isn't tracking all file changes. And so I would suggest to go back and look at that ATP options policy. There is an additional setting for the enhanced remediation engine to track additional file changes. Be careful in doing that though, because I mean, just like any software, the more you ask of it, the more resources it's going to consume, right? And so usually that setting, and I believe it states this in the product guide, the 10.7 product guide for ENS, we don't recommend enabling those additional tracking of changes, file changes, on systems that are very active. So things like servers, if you're wanting to try it out, maybe test it on a couple of machines that aren't too critical to the environment, because the expectation is that you are going to see more CPU consumption of the MFE ATP process. Everything for the enhanced remediation engine runs through that process. So the more you're asking it to track to get that additional cleaning capability, the more CPU that process is going to consume for any given process execution.
Got it. Okay, perfect. Thank you for that one. Is there another location besides the ATP server settings where we can find the JTI rules?
No. I'm having to think about that for a minute. Good question. No, it's only in the ATP server settings, and keep in mind that's just one of the pieces to the scanning, right? That's just the JTI rule stack, or what we also call the TIE/ATP content. There likely are some other methods to review that. Like if we get some debug data, for example, an AM trace, which are things that support and engineering will look at whenever we're trying to debug an issue. So there are a couple other methods to pull that, but from a user perspective, that is the JTI rule stack.
Got it.
Or
Okay,
that's the
perfect.
only, or sorry, that's the only place where you can view the JTI rules.
Oh, gotcha. Yeah, I understand. Okay, cool. All right, perfect. Thank you for that one as well. It looks like that's all the questions that we had for today's session. I want to thank everybody for hanging out a couple minutes late with us to get through the rest of the questions that we had. And I want to thank everybody for joining today's webinar. And a big thank you to our speaker, Aaron. As a reminder, a link to today's recorded presentation will be emailed to all registered attendees. This concludes today's webinar. Stay safe, everyone.